Okay, welcome back to Physical Science Online. Today I wanted to do a real-life demonstration of these velocity calculations with you. We will use this tubing to do some roller coaster labs sometime this year. And basically it's just some pipe insulator, and these are some marbles that actually fit down it pretty well. So that's what I'm going to use as my track. And this is my vehicle, the thing I'm going to measure. And we're just going to do some real life calculations today. So if I want to calculate velocity, all I need is distance and time. I can get distance with a ruler. So we measure here in science things usually in meters or centimeters, whichever one you want to go with. It's just a different scale. And if I can put this up next to here and get an approximate distance, so it's 1 meter to right there. And keep going, looks like 185 centimeters, which is 1.85 meters. That's how long my track is. Distance equals 1.85 meters. Okay, so then I need a time. And to get a time, I just need to measure the time it takes to go down the ramp. So I'm using my trusty stopwatch today. You can use whatever you want when you do something like this. The same principle applies to vehicles, to people, to sports and stuff like that. You get a distance and you get a time. Now the key to this, to understanding this, is that we're getting an average. So if you do a person who's accelerating and then stopping, or who's not going consistently, even a car, even if you have cruise control locked in, is not going consistently. Obviously my track is not the straightest thing ever. It's probably going to bend and flex. So you are getting an average time. You're getting the time from this point to this point, and you're not caring too much about what's in the middle for the purposes of this equation. That being said, let's see if we can get a time or two. I like to do 2 or 3 trials to see if I can get the same time. Ready, set, drop. That was like 1.4 seconds. Let's see if I can, let's see if I was accurate on that. I felt like that one was a little bit off. Ready, set, go. Yeah, 1.7. That's sounding better. We'll do one more just to be sure. Ready, set, go. Now I got 1.4 again. So typically if you did 3 trials, you do an average. I'm going to do a quick average. I know in my head, since these videos are only 5 minutes long, 1.4, 1.4, and 1.7, we'll say 1.5 seconds. So my time is 1.5 seconds. Velocity equation. Really easy to plug in, because if I want to know my velocity, V equals D divided by T. So V is going to equal 1.85 meters divided by 1.5 seconds gives me, making sure I'm still on camera with that one, gives me, I'll actually break out my calculator so I get all the decimal places right here. 1.85 divided by 1.5 equals 1.23 meters per second. So there's a real life example of how this velocity equation would work. If you build a different ramp, if we switch this up, the time might change, but the distance would be the same. So it'd be kind of a cool experiment to do. Get some different times on that. But I just wanted you to get more of a sense of where these story problems are coming from, what they kind of look like, and what we mean by average velocity. We don't know what it's doing in the middle. We can't even see it in the middle. We can only go from one spot to the next. That's where our distance comes in, and that's where we measure the time between, is between those 2 points. Hope that helps clarify a couple things for some of you. And if not, at least it's another example of what these equations look like. So there you go. I'm out.